Okay, so today we're going to be working on expressions that have rational exponents, and that means expressions where the exponent is actually a fraction, and believe it or not, these actually represent roots. So I love this little formula up here. The nth root of x is the same as x to the 1 over n power. That's what it means. So let me just show you. Square root of 36 could also be written, since it's a square root, square is 2, as 36 to the 1/2 power. All right, we did cover this in Algebra 1. You had to simplify expressions written like this. So the cube root of 64, that means the denominator is going to be a 3, is 64 to the 1/3 power. And the fourth root of 16, that means your denominator will be 4, is 16 to the 1/4 power. All right? So that's what we mean by rational exponents. So we're going to go ahead and we are going to write some of these. Our first example here, simplifying expressions with rational exponents. The 1/3 power means cube root. So this is the same thing as the cube root of 216. Now, we didn't have the cube root of 216 on our list, but I feel like it's 6. It is it 6? Okay. So this is 6. But I don't know. This is not as easy to simplify as this. I know what this means. This I find is a little bit more complicated, so I tend to take these and rewrite them this way to simplify them. I find that easier. So now, if we go to this next one here, I've got 7 to the 1/2 power times 7 to the 1/2 power. The 1/2 power means square root, right? So this is the square root of 7 times the square root of 7. And using our product rule from a few days ago, we know this is the square root of 49, which is 7. Okay, next thing, I've got this one. This is a fourth root. So I've got the fourth root of 5 times the fourth root of 125. Now, using my product rule that I learned a few days ago, I can combine these as the fourth root of 5 times 125, which is 625, right? And that is actually on our list. The fourth root of 625 is 5. Okay? So what I want to do next is I'm going to highlight some formulas for you, and I'm going to show you how you go about rewriting from exponential form to radical form and radical form to exponential form. So what I want to do is go down here to our little key concept box, and I'm going to highlight this, which is a to the 1 over n power equals the nth root of a. And we just did some examples like that. Now, this one is super handy. This is if you have a numerator other than 1. A to the m over n power is the nth root of a to the m. You can also write it this way, the nth root of a in parentheses raised to the m power. Either way, doesn't matter. It's all good. Okay? It's all good. So we're going to go to the bottom of the page here, and it says express in radical form. So here's what I want you to know. One of these two ways is what we call radical form. And this way right here is what we call exponential form. Okay, So the denominator is the index of the root. So the denominator is 7. So the index of the root is a 7th root. So this is the 7th root of x to the 3rd. Now the question is, can we even simplify that? Since this is smaller than 7, no, we can't somehow split it up and simplify it, since 3 is smaller than 7. Now this one, oh boy, decimal, okay? Switch it to a fraction. Would you agree? This is negative 3.5, right? You'd agree. 3.5, 3.5? Okay. Make this an improper fraction. 3 times 2, 6 plus 1 is 7. So this is negative 7/2. So now we're going to write it as y to the negative 7/2 power. Now the interesting thing about this is we know what a negative exponent means. Means it needs to go below the fraction bar. So this is 1 over y to the 7/2 power. Fair enough? And now we got to simplify that. Equals 1 over the square root. So we actually don't need the 2. This is the square root of y to the 7th, right? Now, we can split that up, right? 6 of them we can take, because that'll divide by 2, and then 1 extra one. So 1 over square root y to the 6th and the square root of y. Now the square root of y to the 6th is y to the 3rd, correct? What is wrong with what I have? Because we're not done. We do
Square root on the bottom.
We have a square root on the bottom. Rationalize. So times square root of y over square root of y. I'm going to run out of room here. Equals square root of y over y to the 3rd square root of y squared. And what's the square root of y squared? Y. So now you're going to combine this y with this y, and I'm just going to move it all the way over to here. This is the square root of y over y to the 4th.
I keep forgetting for some reason. When you're splitting up the y to the 7, why is it to the 6th again? Like y to the 6, you split it to y to the 6th.
Because it's what's going to divide by the index of the root. The index of the root is 2 because it's a square root, so they have to come in pairs of 2's. So 6 is 3 pairs of 2's.
Okay, that makes sense. Thank you.
All right, let's go ahead and turn the page. Now, we're going to go in the other direction with these examples. These say write in exponential form. All right. What's my denominator of my fraction going to be? 2, because this is the square root. So this is a to the 5/2 power. Okay? What is my denominator in this one? 5. And my numerator? 3. So this is b to the 3/5 power. All right, so those are written in exponential form. What we're going to do now is we are going to use all these handy-dandy laws of exponents that we already covered last week. They all will also work for fractional exponents. And we're going to use them and this new rule that we learned, which is how to switch between exponential form and radical form to simplify some things that we couldn't simplify before. All right, so let's go down to example 4. Would you agree? I cannot simplify the 4th root of x to the 3rd and the 8th root of x squared. I cannot simplify either of those. Here's what I'm going to do. I'm going to write them both in exponential form. So this is x to the 3/4 power, and this is x to the 2/8 power.
Well, you can't
You can, we're going to.
Okay.
This is, 2/8 is the same as 1/4, right?
But I wasn't sure.
Yes, we're going to do that, and that is actually one of the things that you'll need to do. So this is x to the 3/4 power, and if we simplify 2/8, this is going to be x to the 1/4 power. Now, go up here to this rule right here, and we're going to subtract our exponents. All right? So this is x to the 3/4 minus 1/4, which gives us x to the 2/4, and 2/4 can be simplified to 1/2. So this equals x to the 1/2, which is the square root of x. So this whole big thing simplified to this. But we had to switch it over to be rational exponents in order to do that.
That's weird.
Oh yes. Wait until you see how we can do this. Because remember, when we learned about the product rule a few days ago, you can't multiply these because this is a square root and this is a 4th root, right? But if you use exponential form, you can do this.
It's like 3 to the 1/2.
Yes, this is going to be 3 to the 1/2. And this is going to be 3 to the 1/4, right? Okay, now we are going to use this rule right here, and we're going to add our exponents. So this equals 3 to the 1/2 plus 1/4. And I hope you know this by now. You need a common denominator. So multiply by 2 on the top and the bottom. This is 2/4 now. Plus 1/4, it gives you 3 to the 3/4 power. Okay? 3 to the 3/4 power. Now, all kinds of stuff we can do with this. Can't simplify 3/4. Let's switch it back to a root. So we can write it a couple of different ways. We can write it like this. 4th root of 3 to the 3rd power. And what's 3 to the 3rd power? 27. So you could write it like this, 4th root of 27. Or you can also write it like this, 4th root of 3, put it in parentheses, raise it to the 3rd power. You can actually do either one of these. But notice, we switched 2 roots that weren't the same index into one single root.
It's so weird.
I know, it's so cool.
It actually
It's so
is.
cool.
I'm saying that. It's just, that's weird.
So cool. Okay, let's go to the next example. Down at the bottom of the page.
What, this?
Okay, every time you see an exponent that is a decimal, I want you to remember, just switch it to a fraction, okay? So negative 2.5 is this. Negative 2.5 equals negative 2.5, which is negative 5/2. All right? So this is 16 to the negative 5/2 power, which we know that negative exponent means we need to drop it to the other side of the fraction bar. So this is 1/16 to the positive 5/2 power. Now, this would switch into a square root, right? Do we know what the square root of 16 is? 4. All right, so here's how we're going to do that. 1/, square root of 16, put it in parentheses, put the 5 there. And the reason why we're going to put it on the outside instead of the inside is because I know what the square root of 16 is. This is 4. So this is 1/4 to the 5th power, and I'm going to need my calculator on that one, 1024. So 1/1024.
This is absolutely wild.
So cool. All right.
It's cool too, guys. I'll save them.
Okay, we just saved them.
Yeah, they're
All right, let's do the next one. So, first of all, we have a negative here. This is actually okay because we have an odd root. This would be a fifth root. It's fine to have odd roots of negative numbers, so we don't need to worry about it not being real. So, fifth root of negative 32, I know what that is, so I'm going to put it in parentheses, put the 4 on the outside. What's the fifth root of negative 32? This comes from what's on our card. Fifth root of 32 is 2, so this will be negative 2. So this is negative 2 raised to the 4th power, which is positive 16. All right, couple more problems. Okay, these are probably the most complicated of the problems we'll have today. So let's see what we've got here. Would you agree? I've got a whole bunch of stuff multiplied, and I have an exponent on the outside, and if you recall from our laws of exponent, this exponent has to go to everything, right? Okay. How do you take an exponent to a root, though?
What do you mean?
An exponent to a root. So let's switch these so they're all rational exponents. So how about this? Negative 8x, and then this is going to be x to the 1/2, y to the 1/2, right? Square root of x and square root of y is x to the 1/2, y to the 1/2. Now, this is x to the 1 right here. Would you agree? Let's just write it in so we remember that. We can actually simplify this by adding those exponents. So 1 plus 1/2, that'd be 3/2, right? I can get you to agree to that. 1 plus 1/2 is 3/2. So I've got negative 8, x to the 3/2, y to the 1/2, and outside I have 2/3. Now, if you recall, when you've got powers on the inside and powers on the outside, that's when you multiply those powers, right? So let's go ahead and split this up. This is going to be negative 8 to the 2/3 power. Then I'm going to have x to the 3/2 times 2/3 power. This times this. And I'm going to have y to the 1/2 times 2/3. All right, let's simplify what we can. So here, the 2's cancel and the 3's cancel, and that's x to the 1 power. Over here, the 2's cancel, and that's y to the 1/3 power. So far, so good? Now we got to deal with this. This is a cube root. Do we know the cube root of negative 8? Negative 2, right? Okay, so we're going to write it like this. Cube root of negative 8 squared, and then we'll have x, and we'll have y to the 1/3. Cube root of negative 8 is negative 2. When you square that, you get positive 4. So 4x, y to the 1/3 power. And if you want to write it in radical form, here's what you'd have. 4x cube root of y. Okay, let's go ahead to the next example, and it may be hard to see, but this is actually negative here. The negative and the fraction bar are really, really close. It almost looks like just a giant fraction bar, but it is negative. So, I'm going to do this. 16 to the negative 3/4 power. Fair enough? And then I have y to the negative 8 times negative 3/4 power. Agree? Following exactly what I did over here. I actually think this one looks like it's a little bit easier. I'm going to do this one a little bit differently. I'm going to leave the negative there. Would you agree that we know the 4th root of 16, right?
Yeah.
We do. Okay, so I'm going to make this 4th root of 16 in parentheses raised to the negative 3rd power. And here, as a fraction, I can do some canceling. First of all, the negatives both cancel the positive, and 4 goes into 8 twice. So I have, looks like y to the 6th, right? 2 times 3, so y to the 6th. Okay. The 4th root is 16. is 2. 2 to the negative 1/3 power is the same as 1 over 2 to the 3rd power. Fair enough? Okay. And then I have y to the 6th. 2 to the 3rd power is 8. So I can write this as 1/8 y to the 6th or as y to the 6th over 8.